this here. Okay. So I'm just resizing the screen because it doesn't snip well when it's all the way across. And okay, so I'm gonna start sharing my workspace, and then I'm just gonna snip in the questions as we do them, and try to explain what's going on here. All right. Is this totally new to you, or is there a little? Do you have a little bit of a?
We went over it in the last lecture, but I mean, that was on Friday, so.
Okay. So essentially, when you're finding the area between two curves, you've got like a top and a bottom, and then you have an A and a B, like that. And very generally, um, it's the integral of top minus bottom from A to B. So you could graph these, like you don't have to, but we know x squared looks like this, and we know y equals -2 looks like this. So we're graphing kind of this region in there. So when you know what's on the top, you can essentially, I don't know why it won't let me scroll here. Scroll down, it's upsetting. Okay, let me insert some white space here. I don't know why it's doing that. There it is. Okay, so for this one, we're going to integrate from -1 to 1 x squared minus a -2 dx. And we've essentially converted this into a problem you did last week, a definite integral, x squared plus 2 dx. So you find the antiderivative, x cubed over 3 plus 2x, and you evaluate it from -1 to 1. That's 1/3 plus 2 times 1 is 2 minus, and then -1 cubed over 3 plus 2 times -1. So this becomes -1/3 minus 2, and then there's a negative on the outside. And so it becomes +1/3 plus 2. So 1/3 plus 2 plus 1/3 plus 2. 4 plus 2/3. 4 is really 12/3. So I believe it becomes 15/3. Would you like me to enter the answers as we go?
Yes, please.
Okay.
How do you do it on the calculator where you're like converting it to a fraction?
It's math and then enter.
Oh, got it. Yeah, 14. Okay. Or is it 14/3 or 15/3?
14/3. I entered that wrong. Thank you. All right, so now the next one is minus, well, let me snip it in. I'm talking about it, but you can't see it. Okay, so the graph between y equals -x and y equals x. So y equals x looks like that. Y equals -x looks like that. And we're going from 0 to 5. So from 0 to 5 there. So we're trying to find that area. It's the integral from 0 to 5, top minus bottom. So x, this becomes x plus x or 2x. And this becomes x squared when you find the antiderivative from 0 to 5. So it equals 5 squared minus 0 squared. So just 25 for that. Entering that now. Any questions on that before moving on to 3?
No.
Okay, moving on to 3. So they won't tell you this in class, but you can actually choose wrong. If you graph the wrong order of integration, because your area has to be positive, the way these are between, if you choose the wrong top and bottom and you get a negative area, you just negate it. For these particular type of problems, which is totally wrong. Like, you don't want to do it that way, but it does work. You know, it
Mhm.
works, and it always works. So this is minus x cubed. This is minus x. Okay. Um, so what's interesting here is that I guess that it switches, like one curve's above the other in one place and one is below the other in another place. There's yet another workaround for this. Um, did you have to show work? Do you think you'll have to show work? Is that important to you for when you're doing
No,
a? Sorry,
no,
could you?
it's
No, okay. So what you can do, and if you're using, especially if you're using a technology, is you can go to the integral minus 1 to 1 absolute value minus x cubed minus a minus x, and the absolute value takes care of all this, up or down. If you didn't do this, you'd have to integrate from minus 1 to 0, minus x minus a minus x cubed dx, plus the integral from 0 to 1 minus x cubed minus a minus x dx. You'd have to know to switch the order of the terms because of the fact that it's one's on top, one's on the bottom, in one region versus the other. You'd have to know to do all this on the left, or your technology will do this on the right. So you have an absolute value button in your calculator, so you can actually just
Mhm.
use the ABS on that. It sounded like you were doing these along with me. That's
Mhm. Where is the ABS?
should be under math, and functions maybe.
Um, I don't see it.
Let me see if I can find it. You're using a TI 84.
Is it there?
84.
Oh, I found it.
Found it. Okay, great,
African number.
great. So the answer here is 1/2 when you're done with all this, and it's a pretty big shortcut. Like we're really, like, this is not the way that they want you to do it, but it is the way that you can do this quickly without really knowing how to do it.
Okay. You did the absolute value of, you plugged in -1 or
No,
what?
negative. You go from -1 to 1, but your integral, like your TI 84 has an integral. You can put -1 to 1. You can put the absolute value here and here,
Hmm.
and then you can even switch the order of these, but it's minus x cubed minus a minus x
Okay.
for that.
It's, oh yeah. It's, um, I remember how I did. We did it in class where you enter in your calculator second calc 5. Is that what it is? No, that's truth.
There is an n deriv and an n int for this, it, there's a little disconnect here for me because I don't have one of those in front of me. And
Oh, I found it. It's,
okay,
yeah, I found it. Okay.
if you didn't get 1/2, we can talk more about it. But let me know when I can move on to the next one.
Yeah, you can move on.
Okay. So one of the, again, kind of like this is like the next level up where, um, you maybe don't know where these graphs intersect. So like, um, you have to know what these graphs look like. I mean, you could graph them, obviously. There's y equals x, and there's x to the fourth. You need this point. You need the x value. So to find that by hand, you have to set x equal to x to the fourth.
Mhm.
And I mean, or you can just graph it and find the
Yeah.
intersection. I mean, it ends up being at 1. So I mean, it's one of those things where like we can spend time doing this. You get 1 minus x cubed equals 0. So you end up finding that it's either x equals 0 or x equals 1.
Okay.
And that's the. This time they don't give you the integral. So it's integral from 0 to 1. Now, let me try to illustrate that point that I was making. Let's say you didn't know that x was on the top, and you're like, well, I think it's x to the fourth minus x, which is wrong. But let's just go with this for a moment. This becomes 1/5 x to the fifth minus 1/2 x squared evaluated from 0 to 1. So you're going to end up getting 1/5 minus 1/2 minus, and then this is all 0 over here. So 1/5 minus 1/2, well, that's minus 3/5.
Mhm.
And at some point, the instructor, it should have been made clear, like when you're doing an integral, the area between two curves is always positive. So this can't be true. This cannot be true. So it has to be. It ends up being that it's 3/5. Well, that's because we did the wrong order of integration. The top is really x minus x to the fourth. So it ends up being 1/2 x squared minus 1/5 x to the fifth from 0 to 1. You end up getting 1/2 minus 1/5, which does equal 3/5. So the point here, I guess, is that it could be um, it could be that you do it completely wrong, you get a negative answer, you just change it to positive, and that's okay. I mean, it's just
Mhm.
it's allowed. So, oh, it didn't like that. Did I not subtract these? 5. Um, hmm. Maybe I stopped. Huh. 3/5. It doesn't like 3/5. Okay. Let me. I need to check this on something else because I don't know why it's not right. If you've got your calculator handy, you
Mm.
can just verify this one on the right is 1/2 minus 1/5. 0.5 minus 0.2 is 0.3. Oh, 2/5. God bless it. That's should be. I think it's 2/5.
Okay. Mm.
Another 1/2 minus 1/5 is 3/10. Completely wrong. Wow. I'm sorry. I just not giving the correct information. So it's really minus 3/10, which I said becomes 3/10. So it is 3/10.
Okay. Yeah, I just
Um,
got 3 from my calculator.
okay, great. Um, all right, number 5. Okay, find the area. So we kind of already did this one. Like this was the same as number. It's the same as this one. Number 5 is the same as number 3. Um, so again, that graph looks like this, and then you got that line going there like that. So
The same numbers too?
yeah, well, it ends up being the same points, 1 and minus 1. So
Yeah.
you're integrating from -1 to 1.
Mm.
So it's exactly the same. You can do the absolute value minus x minus a minus x cubed, and you end up getting whatever we got in that problem, number 3, which is 1/2. This is the same as 2. 3. Same as 3. Okay. All right. We can move on to 6.
Okay.
This one says to round to 4 significant digits. So that, to me, that's like immediately we're going to go to a calculator or technology with it. And I assume that's what your instructor wants. You can do it the same way I mentioned. So this is your A, this is your B, -1 to 1. You don't know which one is the top or the bottom. You could try to figure it out. Like e to the x goes like this, and 2x plus 1 actually hits there too. So I'm going to guess there's kind of a, I'm going to guess that 2x plus 1 is up there. But it's going to be 2x plus 1 minus e to the x dx. So why don't you try that in your calculator? I'll do it as well, and we'll see if we get the same thing. Oh, you know what? I'm sorry. There is something really crucial here. So I didn't realize the lower bound. So see how this goes to -1.
Hmm.
So you actually do have to do an absolute value on this.
Oh, okay.
Otherwise, you have to break it apart into 2 separate integrals.
Okay.
You can always use the absolute value though. Like you don't have to. You don't have to.
So you do the absolute value of, okay.
Yeah, absolute value of all that.
Is it 0.913?
I got something different. Well, I wrote it down here. 0.9138.
Yeah, that's what I got.
Oh, I'm sorry. Maybe I misunderstood. Okay.
Mhm.
Okay, so let me just enter that in. We're both in agreement on that. All right, so 7 is exactly the same in terms of like it's completely a calculator problem. Because of this absolute value thing, you can be really, really uncaring about what you're doing. It's the integral from -2 to 2, absolute value, and it doesn't really matter. Let's just do x plus 2 minus 2 to the x dx.
Okay. 2.6 repeating.
Yeah. Yep, that works out for me as well. So let's try that out here. Okay, so that's correct. Now we're on to the last one here. Sorry, let me get this snipped in here. There it is. Okay. Suppose your annual income is this and your expenses are this. They want you to find the area between the graphs. Again, you don't really need to know, but you would assume your income is greater than your expenses.
Mhm.
So it's going to be I of t minus E of t. You're integrating that, and it's for 3 years. It's going to be from 0 to 3. So it looks like it's going to be the integral from 0 to 3, 49,000 plus 2,000 t minus, and this time you got to be a little bit more careful to put in parentheses. I didn't really emphasize that in the previous problems, but you are subtracting the whole quantity. And t could be x, could be any letter. If you're more comfortable, you can put it in as as x instead of t. This one you don't have to do the absolute value, but you can actually always do the absolute value if you want to, and it'll always give you the right answer.
Okay.
So let me plug this into our
Got 1,500, 150, 15,150.
I got a slightly different number. Let me see if if I enter this correctly. I got 23,250. $23,250.
42000.
Let me check mine again. 49,000 plus 2,000 minus
Oh
42,000
wait.
plus.
Oh, I put 200 instead of 2000. That's why.
All right, let me enter this value. Now the second one is this drop down here. If you were to do it from 0 to 1, that would be the amount you saved in year 1. 1 to 2 would be year 2, with 2 to 3 would be year 3. So it's the total amount you're able to save for the first 3 years. All right, we're through that, and full mark on that. So let's go to 14.3. Wonder what that'll be. All right. So I have to snip this in 2 parts. The average value and then the graph. Graph's actually pretty straightforward to do. Okay, so find the average value of the function over the given interval. Do you remember this from class?
Let me look in my notes. Oh,
So the average value is 1 over b minus a integral from a to b
oh,
f of x dx.
oh, we're on 14.3. Okay.
Yeah, 14.3. So the only thing that's different about this is this thing in front.
Mhm.
It's still a number when you're all done. So this one is 1 over 1 minus minus 1 integral minus 1 to 1 x cubed dx. So this out in front becomes a 1/2. This is 1/4 x to the 4th antiderivative from minus 1 to 1. And then you just multiply all that by 1/2 whenever you're done. So this
Okay.
becomes 1/4, 1 to the 4th, minus 1/4 times minus 1 to the 4th, and times 1/2. So the average value here, interestingly enough, is that this inside part becomes 0. So the whole thing becomes 0. So you might think that that is wrong. or not right or whatever, whatever the right wording is on that. But let's look at the correct graph here. So the average value is a horizontal line. And it's y equals whatever the average value is. Okay. And it's like a balance point
Mhm.
between the top and the bottom. It's basically saying, like, if you took all of this area and you back countered it with all of this area, where
Then
would it be? Well, it'd be right here in the middle. So that's graph on that's the lower left one. I didn't show you the other graphs because they're all wrong, but
Mhm.
we can. Okay, so we'll go to number 2. Whoa, whoa. I'm sorry, that was weird. Oh, am I? Oh, I see what's going on. I'm so sorry. I've not had that happen before.
Did it glitch or something?
Yeah, my I'm showing I was showing something on my other screen on this screen, which wouldn't be helpful at all for you. So let me get that back up. Why is it doing that? Huh. Okay. All right, let's go standard. Okay, so got technology figured out. All right, so find the average value of the function over the given interval. So this is your a, this is your b, your f of x. Obviously, it's 1 over 2 minus 0 integral from 0 to 2 x cubed minus x dx. So you could absolutely use technology. I mean, you can do this by hand.
Mhm.
It's completely up to you. 1/2. This is 1/4 x to the 4th minus 1/2 x squared, and this is evaluated from 0 to 2. 1/2 times 1/4 times 2 to the 4th minus 1/2 2 squared minus 0. All of them evaluated at 0. 2 to the 4th is 16 over 4 is 4. This is minus 2. So it ends up being that it's 4 minus 2, which is 2. 1/2 of that is 1. So the average value is 1. So when we're looking at the graphs, and I guess I know you can't see it, but you're looking for the one that goes through y equals 1. There's only one of them that does that. Let me snip that in to illustrate that, because it's kind of important to know. I know you're not taking physics or statics, but what we're actually doing is calculating a balance point or a center of mass in the y direction. So see how this is y equals 1 here. It's kind of like this area and this area are balanced.
Okay.
Maybe that's interesting. Maybe it's not.
Yeah.
I'm not. I'm
Mhm.
not sure. Um, okay, so we're up to 3. Are you coming home for Thanksgiving?
Yeah, I'm probably gonna go home on like Sunday or Monday, but I'm
Great.
gonna come back up for finals because
Awesome.
I can't do my finals in my house.
Yeah. All right. Yeah, it's better to live alone. All right. So this is the same thing, a and b, 1 over a b minus a. So it's 1 over 1 minus a minus 1, minus 1 to 1 e to the x. When you integrate e to the x, it is itself, and you're valuing that from minus 1 to 1. So this one says 1/2 e to the 1 minus e to the minus 1. And this one says to round to 2 decimal places. So
Mhm.
you can just verify that in your calculator. I mean, it's going to be, I don't know, it's going to be some positive number. It's going to be, I mean, it's going to be about 1.25 or something. Let me get
Yeah, 1.18.
okay. So now I'll tell you how I can, the way I did it. I mean, I didn't calculate it, but you'll see graphically how you can determine this. I looked at all 4 graphs they provided. This area looks to be the same as this area.
Mhm.
And I thought, yeah, let's go with that here. 1 point.
Is it just because it's like since it's around one, that's what it would.
It's because that okay, let me. So I did what I didn't do. Let me show you one that's wrong, and then you can see how you can do it. It's more of a visual exercise. So this one is not correct down here. If I go from here and here, look at all of this weight compared to all of this weight. See how it's
Yeah.
much more on the
Right.
right than the left. That's why you have to. It's a sharing problem. Like, well, if we come up here, it looks like it's a little bit better.
Uh-huh.
Which is why how I
Oh,
knew it was kind of about that value.
so is it like does it look even because it's 1 to -1?
It's whatever that horizontal line is, whatever's underneath of it between the intersection points has to be the same.
Oh, okay.
So like a more, I don't know, let's say you're integrating a rectangle from 2 to 4. Well, the center line's here because there's going to be some below it and some above it. It isn't a good example.
Mhm.
Um, if it, like something like this, see how there's the same below as above.
Mhm.
That horizontal line is what we're trying to figure out.
Oh, okay. Okay. That makes sense.
What the heck is this? I have not seen this problem before. Calculate the 5-unit moving average of the function.
Okay,
Actually,
I have an example. Okay.
okay,
I can send you a picture of my notes because there's an example and it's like a whole algebraic mess.
okay, that
I
works.
can text it to you or something or email.
Let me just do a quick search and see if I can find it, because it may be maybe a better explanation if I can.
Mhm. Under it's like it goes from x to x-5, the integral. And it's like the number in front is 1/5.
Yeah, I mean that makes sense.
Yeah. So it would be like 1/5 and then x-5, and then you put in the function.
Okay, okay. So I see this here. This is totally doable. Moving averages are used in business classes. I didn't know they're putting it into this class. They actually show a lot of moving averages on the COVID data if you watch the news. Okay, so like you just said, um, it's the integral from. Let me just get that up here again. It's from. Okay, so we have x to x minus n,
Hmm.
and then it's 1 over n is generally what it
Hmm.
is. But for this problem, because it's a 5-unit, we're doing it from 1 over 5 integral x to x minus 5. Is that right?
Hmm.
Okay. Um, so then, and you're doing it for this function x to the 2/3 dx.
And then it looks like in the example, they plugged in. Yeah, so they did. They when you expand it, it's like it would be like 1/5 times like the you plug in x, then you do minus the x-5. So like it's just like so much. It's just a lot of like algebra 2, like cross.
Yeah,
You know.
right. With WebAssign though, you can actually just enter it in as a like
Okay.
as a thing. You don't have to simplify it. So like, for example, you just said it here. It's the antiderivative is x to the 5/3, 3/5, 1/5.
Mm.
Okay,
Okay.
and and you can then put these things in without actually simplifying it. So it looks like 3 over 25 evaluated from x minus 5 to x. The x goes back in, so it becomes x to the 5/3 minus x minus 5 to the 5/3. Like you can just leave it like that, I believe.
Okay.
Let me try that. I assume that will work. All right, and then the graph of it, we have to graph it, which I actually have no idea how they're asking how they want you to do that. I guess you just graph it. Okay. Oh, I see. Oh, I did choose a graph accidentally. Okay. I guess you just graph this. I don't know how else to do it.
Mhm.
And see which one
Yeah,
is.
and this one, I don't even know what.
It looks to be. This is always it doesn't really look. It looks like several of them. Okay. All right. It's either, wow, they all look kind of the same. Why? Uh, Let me show you what I'm looking at. I'm graphed this on my other screen, and I'll snip that in here. Um, well, that doesn't help. You're not looking at the WebAssign, are you?
No.
No. Okay. So that won't help. Oh, I see. So yeah, you kind of have to do it by the y-intercept. You can just look at it later. It's not super important
Okay.
for that. Let's do 7 next because it's kind of the same thing,
Okay.
and then we'll come back to 5 and 6.
Okay.
Is this going okay for you?
Mm-hmm.
All right, calculate the 5-unit moving average. So we know that this is x minus 5, 1 over 5, x cubed minus x. So the antiderivative is the 1/4 x to the 4th minus 1/2 x squared. Now the nice thing about WebAssign is you don't have to do all this simplification. You can bring that 1/5 down. We'll say 1/20th, and then you insert that top x. So it's x to the 5th minus 1/10 x squared minus now 1/20th x minus 5 to the 5th minus 1/10 x minus 5 squared.
And
And so that's your answer. You can expand those and combine like terms and do a lot of things. I don't want to do any of that. So let me just get this entered in carefully. I don't know if I can copy this into my graph. That would be really nice to get the graph of this. Oh, it does work. Is that an option? That graph doesn't look right. Okay, let's see if it'll accept that. Did not accept that. Okay, what am I missing here? Oh, it's x to the. I'm sorry. I completely this antiderivative. I'm sorry. I'm not on top of my
Oh,
self today. Um, that's also why the graphs look so wrong. Four. Let me change them over here. Four. Oops. Four. Yeah. Okay. So that does actually look a little more normal. Let's see where it cuts through. It cuts through around 2.5. So it looks like it is that one there. Okay, 4, 4. All right. Okay, so that should be it. Okay, so that yeah, that worked out. That worked out there. So you can look at that later. All right, we're up to number 5. If you invest $25,000 at 5% interest compounded continuously, what is the average amount in your account over 1 year? So they're telling us that's from 0 to 1. And then you have to convert this to a formula. So continuous compound interest is PE to the RT. So 25,000 E to the 0.05, we can say T or X. So you're integrating 1 over 1 minus 0, that's the average part, from 0 to 1, 25,000 E to the 0.05 X dx. And I'm going to use a online calculator to get the value of this. The number out in front is just 1. Okay. Oh, it didn't give me enough digits. It didn't give me enough digits. Okay. So did you do this on your calculator?
I'm doing it right now.
Okay. It's to the nearest cent, 635, and then mine didn't give me more.
Wait, did you get? Oh wait, I 25000 E to the. Oh, I did point. Wait. Yeah, I got point. Oh, I got 25635.55.
Okay.
That's,
That's probably reasonable enough. Mine just went to 0.5 because it said we're not, those digits aren't
I got
significant.
0.54819.
Okay. 25635.55. There's usually a little tolerance for these things, so it did take that. All right, last one. Okay, suppose you have an account paying no interest in which you deposit $5,000 at the beginning of each month. You withdraw money continuously so that the amount in the account decreases linearly to 0 by the end of the month. Find the average amount in the account over a period of several months. That's like t equals 0 to 1. Huh.
What does it mean by several months?
Yeah. Like, do they mean? I don't know. It's a weird question. What's nice is the internet is full of people that like you and I have no idea what they were asking for you to do, and they usually shed some light on what the heck you were supposed to do on this. Um, This one is not reasonable. It kind of feels like it's related to that problem that we're doing with the moving average.
Mhm.
Um, but you don't know. It's like you're supposed to go integral x minus n 1 over n, and then you have $5,000. So after you deposit at the beginning of each month, you withdraw money continuously. Um, let's see if this one has a try another version, or let's see if it's got.
Yeah.
I don't ask your teacher. Practice another. Great.
Mhm.
So I usually just put in a value and then show answer to maybe get a. So this is not helpful to teaching or trying to explain it to you, but we can. I'm gonna just snip it in here. You just sort of say, oh, I guess it's half is what they want. I don't know why. I would definitely ask your instructor. Do you want me to enter in 2,500 for the answer
Yeah.
on this?
Yeah,
Okay.
go for it.
Okay. All right. That's it for us tonight.
Did it work? 2,500.
It did. It did.
Yeah.
Full score. So I'm going to send you a PDF of the notes and the screen recording here shortly. Thanks again for scheduling, and
Yeah. Thank you.
I'll see you next time.
Right. Thank you. Have a good
You're
night.
welcome. You too.